Hi, on today's video we're going to be going over the notes for chapter 13.1, which is on trigonometric graphs. So we have been working a lot on trigonometric graphs, so we've looked a lot at the sine function and the cos x function. We've looked at what happens when we put a number in front of the function, so like 2 sine x. We've also looked at what happens when we put a number next to the x, so for example like 2 sine 3x. And lastly, in the last lesson, we looked at what happens when there's a number at the end of our function which shifts it up and down, so something like 2 sine x plus 1. Okay, so they're all lessons that we've done that you should have took part in before watching this video. Okay, this is going to complete the chapter. So just to go back in a bit of revision, we have got these three functions, sine x, cos x and tan x, and they look like that. In the very first video we were drawing out these curves and exploring how we got them. Okay, from on then we should now know the following terms. So the amplitude is the distance from the midpoint to the highest and lowest points in the graph. Okay, so it's the number in front of the function, like for example 2 sine x, that changes the amplitude. Okay, it changes the heights of the graph and also how low the graph goes. So for example, sine x you can see only goes up to 1 and -1. However, if we had 2 sine x, it would go up to 2 and -2. The period of the graph is the number of degrees it takes for the graph to do one complete cycle. So for the sine graph and the cos graph, if it's just sine x and cos x, the period would be 360 degrees. That's how long it takes for it to complete its cycle. However, we have seen that that can change. If we have something like sine 2x, that means we've got two sine curves in the space of 360. Therefore, the time it would only take for one to complete itself would be half of that. Okay, so the first one would actually finish in 180 degrees. Okay, the frequency is also another term that's commonly used. Okay, and again, it talks about how many times it repeats itself in 360 degrees. However, for a tangent graph, we need to remember it's actually 180 degrees we need to look at the picture for, okay? Because a tan graph completes its cycle in 180 degrees. So we're going to look at these three questions. Now I've actually changed the first two questions to in your notes, so can you make the changes? Okay, so you can either draw on the back of your notes or do this in your jotter. Just make sure you pause this video to change those questions. What we're going to do is we're going to calculate the value of these functions at a specific point. Okay, now it's very important to understand these questions would normally be non-calculator questions, so we've got to use our graphs to get the answer as opposed to just put numbers into a calculator. Okay, so we'll look at the first question. We're given f of x is sine 2x. Now we're not asked to sketch this. All we're asked to do is calculate the value of that function at 45. Okay, and that's what we're going to do. So the very first thing we do is we're going to put 45 into this function here. So what this function is the sine of two lots of x. Okay, so that means I need to work out what the function of 45 is, which means it's going to be sine of two lots of 45. I've just swapped the x for 45. So two lots of 45, that would be what is the value of sine at 90. Okay, and you can see why we don't need a calculator now, because we should know the answer to what sine of 90 is from our graph. So if you go up, we should actually know this off by heart by now, but we're going to look at what the sine curve is at 90. So the sine curve is the one on the left hand side, and you can see here that at 90 degrees we are at a height of 1. Okay, so the value of sine at 90 degrees is 1, so the function at 45, changed it to sine of 90, that means my value is 1. Okay, so that's how I got the answer to that. We'll look at the next one. So we're given a function g of x, and it's going to equal 5 lots of the cos 3x curve. Okay, but again, we don't need to sketch this out or get a calculator. We can do this as the following. Our job is to work out the value of this function at 90. So we're going to put 90 into my function. So that's going to be 5 lots of cos times, now it's going to be 3 times 90. I've just swapped that x for 90. Okay, so let's work this out. So that's going to be 5 lots of cos of 270, because 3 times 90 is 270. And again, you can see we don't need a calculator at this point. Okay, calculator will get us the answer anyway, but we don't need it. This could be a non-calculator question. We need a graph. Okay, so I've got the cos graph above. What I'm going to do is I need to work out what cos of 270 is, and then I'm going to times my answer by 5. So if I go up to the top, I see cos of the graph here, and at 270 degrees you can see the cost graph is 0, so that's what the value of cost of 270 is. It is 0, so that's going to be 5 times 0, 5 times 0, oh I was going to write 5, oh let's try it again, is 0. Okay, so that is the value of that function. When we put 90 into it, okay, it changed to cost 270, that was 0, so 5 times 0, we got 0. Okay, next question, we're going to write the following in order of size, starting with the smallest. So again, you can see that we're going to need to use our graph here to get this, okay? So I need to work out what the values of the sine graph are at this point, okay? At these points here, so 120 degrees, 270 degrees, and 305 degrees. Now they are not, all of them are not the ones that we normally use. We normally use 90, 180, 270, which I do have, at least that one's good, but I don't have 120 or 305 on my graph. So what I need to do is think about what those values would look like. So sine of 120, let's go up to my graph and let's locate where that would be. So 90 would be shortly after 90 degrees, 120 would be shortly after 90 degrees, but well before 180. And you can see it'd be about there somewhere. Okay, so that would be sine of 120 there. Okay, now sine of 120, you can see that it's there. We don't know the value of it. It's going to be lower than 1, but the main thing is it's positive. Okay, it's above the x-axis. My graph is actually positive at that point, so that's good enough for us just now to work out that, I don't know what the exact number would be, but it's going to be bigger than 0. Okay, sine 270, well I know what that is. Okay, that's one that I do know on my graph, so let's go back up to my graph. Sine of 270 would be there, which is down at -1. Okay, so that's one of the points that we should know. So that is not a guessing game, we know that is -1. And the last one that we need to know is sine 305. And again, all I want to know is what does it look like. Okay, so the key thing is sine 305, well it's going to be negative, 305 would be about there, so therefore about there. But the main thing is, it's actually going to be slightly bigger than what sine 270 was. Okay, so yes it is negative, okay, so it's actually between -1 and 0. Okay, so I'm going to write that as sine 305 is in between -1 and 0 there. Okay, so that's my three values. Now my task was to put these ones in order starting from the smallest. So the smallest one, okay, so the very lowest that the graph gave me there was sine 270. So let's go sine 270. Let me write that again. So sine 270, then it goes sine 305 because that was still negative, but it was slightly bigger than sine 270. And then the one that was positive will be the biggest one, which is sine 120. So at no point did I use a calculator, I just used my graph to work out the answer to all those three questions. So make sure you pause this video a few times to understand exactly where I've got my answers from. Okay, we're going to move on to the next part, which will be 13.1 part C. So these are more types of the question. I have changed the first one so that if you can change that too, that'd be great. We're going to go over this one here. So we're looking at the graphs of the form a sine x plus c or a cos x plus c. So again, a is the value that tells us the number in front, which means it's been stretched, and c means that there's been a shift, so either it's been shifted up or it's been shifted down. Okay, and we've actually got two questions where they've gave us the graphs, and our job's to work out the answer. So let's think about what this graph would be. Okay, so our heights are not equal, as in we have a different number at the top and a different negative number, so that means it has been shifted. Okay, now you can see that the middle of the graph would have been there. Okay, so that's normally where the x-axis, so this has been shifted up, and our job is to work out what it is. What we need to do is work out the gap between there and there. Okay, so what we'll do is we're going to subtract these two values. Okay, so we're going to go 5 take away -1, which equals 6. So that means the tallest in the bottom part of my graph there's a distance of 6, but we only want to know where the middle would have been. So if we divide 6 by 2, then that gives me 3. So therefore A is 3. So that means our graph would have originally been at 3 and negative 3. So if it's been changed from 3 and negative 3 to 5 and negative 1, that means if we think about just the top part, if it was originally meant to be at 3, but the tallest is now is 5, that means it's went up 2. Okay, so that means C must have been positive 2 as the graph has been shifted up. Okay, and if you don't understand exactly how that is, if you don't quite fully work that out, what to do is, now the fact that we've worked out it's 3 and 2, sketch it. Sketch the graph y equals 3 sine x plus 2. Okay, and you should see that your graph will end up looking like that there. Okay, we've got another one to try. So we've got y equals a cos x plus c. So again, we need to work out the value of a. So we're going to add these two numbers, not add them, we're going to take away these two numbers there to work out the distance. So it's going to be 3 take away negative 1, which is 4. We're going to divide that by 2. So a is going to be 4 divided by 2, which is 2. So that means our graph would have been 2 cos x originally. Okay, so if it was 2 and negative 2, that means it's been shifted upwards, okay, to 3 and negative 1. And if it was the tallest part was meant to be at 2, but it's been shifted up to 3, that means that C has been moved up 1 to 3, which means that C is positive 1. Okay, in fact, you don't need the positive there, you can just write it as plus 1. Okay, so C is 1. I've worked out my A and my C value. Again, just to check that you feel that you're confident you've done that right, sketch it. Sketch this with the proper values in now. So if I ask you to draw 2 cos x plus 1, you should end up with a graph that looks like that. But the A and C values are stated there. Now we're actually going to be asked to sketch an example of this. So we're going to sketch the graph of y equals 2 sine x plus 1 for the graph between 0 and 360 again. So what we're going to do is we're going to take it one bit at a time. So let's draw a quick sketch. I'm going to draw my set of axes. Okay, I'm going to draw the sine curve first of all. So the sine curve goes up, comes down, and goes back along. Okay, starts at 0, 90 degrees it's there, and 180 degrees is in there, and 270 degrees is there, and 360 degrees is there. Okay, and if it's 2 sine x, that means my height is 2 and negative 2. Now if we are then shifting this graph up 1, okay, so we're going to draw the up 1 bit, it means every point goes up 1. So it means it's going to start at 1, okay, at 90 degrees it's going to be up at a height of 3, 180 goes up to 1, 270 is at negative 2, so it's going to go up to negative 1, so let's put that in there. At 360 degrees it's going to go up to 1, so we're going to sketch that. It's maybe not the best sketch in the world, but we get the graph y equals 2 sine x plus 1. Okay, so these are all questions that we have been practicing a lot of. Okay, they're just an example so that you can fill in your notes, you can always refer back to. Make sure you ask me if you have any questions on the following examples. Thank you.